Hi. Okay, so I'm using my phone because this is the only way I figured out how to do this. So for problem one, it was the following house prices, and then I was supposed to find the mean and the median. And so I already did my work. I already did like all of them, and I was just gonna explain it because I figured that'd be easier and not take as much time because I work a little slow. Um, but out of the data points, we have I have them all right here for the mean and median. You just split it, mean, all of them together, divided by, yeah. I got 224,500 for the mean, and the median I took 145 and 155,000 and add the divide, yeah. And then I got 1,470, what? 1,470,500. And then it asked which better represents a typical housing price, the mean or the median. And I said the median because it's the one in the middle. The mean is all of them together. And then so the median would be better for the typical, especially for this one, because it's saying explain how the outlier affects your answer for the third part of it. And the outlier is what drags up the mean. So the mean would be most affected because it pulls like the mean up, so it makes it skew to the right, which is why the median is better to explain the typical. And then for problem two, it was the 5-number summary and box plot outliers. So the numbers are 55, 60, 62, 65, 68, 70, 72, 75, 80, 85, 95. For the 5-number summary, I wrote them all out, and then I kind of divvied it up. So the minimum would be 55 because it's the lowest. Then the median is 70, the one in the middle. And then the max is 95 because it's the highest number. And then after I got those, I split it into two after the median. And then so the one in the middle, which would be Q1, is 62. And then on the right side, the one on the middle, which would be Q3, is 80. So then for my box plot, I have a beautiful little drawing. Right here, I have the min, and then we go to Q1, box, median, Q3, 80, and then we go to the max, 95. And so that was all that question was. Yeah, making sure. Problem 3 is the 6895 99.7 rule. A package weighs shipped by a company are approximately normal with a mean of 12 pounds and standard deviation of 2 pounds. And so the first one was what proportion of the packages are weighed between 10 and 14. And then, so for the 10%, it's equal to 12, which is the mean minus 1 standard deviation. And the same for the 14. So it would be 68 because it's within 1 standard deviation of the mean. And what proportion weigh more than 16 pounds? 16 equals 12 plus 2 standard deviation for the mean, so it's within 95. Because it's within 2 standard deviations of the mean, so it means the 5% would be out. Yeah. And use and briefly justify the rule for your answers. Since they're like approximately normally distributed, we apply the rule to estimate like the proportions of each without having to get into like calculations and mathematical things. But basically all because it says that it's approximately normal, we can assume that we can use the rule because of the standard distributions from the mean. Yeah. And then so for the fourth one, it was the SAT math scores. They are normal with a mean of 500 and standard deviation of 100. And so the first one was find the score that marks the top 10% of students. So that would be the 90% because it's leaving out. So yeah, so 90%. So you look for 90% in the z-score table, which was I looked for the closest to 0.90000, and then that would have been, and what I found was the z-score of 1.28. And then so I did the formula of x equals 500 plus 1.28, which is a z-score, and then times 100, which is a standard deviation. And then so I got 628 is the 10% cutoff. So that was my answer for that one. The top 10% of students is 628. Yeah. And then for the second one, it was find that marks the bottom 25% of students. And then so I did the same thing. Since I'm looking for the bottom 25%, I found 0.2500 in the z-score table. And I got negative 0.674. And then so I converted it and used the formula again. So I did x equals 500 plus the z-score, negative 0.674 times 100, the standard deviation. And I got 433. So that would be the bottom 25% of students. And for the third one, I just showed my work, so I needed a bigger page. But yeah, that was all my work for the first one. I circled the final answers. And so for the last part of this question, it says, show your work, convert z-scores, and use a standard normal table or calculator and translate back to the original scale. So from this, I was kind of confused what the question said, but what I got from it is what we did in class, where we do the two separate tables. The one was the SAT, and then one is the z-score with the standard deviations and stuff at the bottom, and showed the top 25, or the bottom 25 and top 10. So that's what I did, because I think that's what it's asking me to do. And so this is the SAT. So you can see, because the number we got for the 10%, the top 10% was, the number was 628. So then that's how 628, it's a little over 600. And then all of that would be the top 10. And then for the bottom 200, we got 400, or the bottom 25%, we got 433. And then so it's 433, kind of around there. And then that all lower would be the bottom 25%. And then the same thing with the z-score, because those would both be median, so I changed it to 0, -1, -2, -3, and then 0, 1, 2, 3. And then it's just the same thing for the z-score, because the z-score for the 10% was 1.28, so 1.28, and then negative 0.646. So like, kind of like, the proportions aren't the best because decimals and stuff, but yeah, because with the standard deviation. So that's how I translated the question, and so I did what I thought it asked me to do. So those are my curves, and yeah, I think that was all. Yes.